Advancing technology has made contamination a much more sophisticated problem to control. Before we get into the causes, however, we want to emphasize that contamination is as much a business issue as a technical issue. The potential costs of failing to take aggressive prevention measures against contamination are failure to obtain the maximum productivity out of equipment purchased for its superior performance, invisible declines in operating performance that occur before contamination problems are identified, which can be as high as 20%. Totally unexpected operating performance problems and failures associated with brand new systems that experience contamination from sources other than wear. Extended equipment downtime, caused by both the difficulty of cleaning systems with outdated procedures and the possibility of repeat system failures caused by inadequate cleaning of contaminated systems. The potential dollar costs associated with these problems are even changing the economics of the industry. Manufacturers are now publishing oil cleanliness standards for their machinery and components. They are mandating conformance and rejecting warranty claims for contamination-related failures. These very same components are on your hydraulic machinery and equipment. Research has proven that clean oil and a clean hydraulic system are the keys to longer system life and less downtime. But what happens to clean oil when it travels through newly installed hoses and tube assemblies that have not been cleaned? The particles of contamination from the cutting, crimping, bending, and flaring process create a problem that will cause premature wear and system failure. 80% of hydraulic system failures are caused by contamination. Premature wear and system failure can be greatly reduced by the installation of clean hose and tube assemblies. To see why, we need a better understanding of what contamination is and how it damages systems. Contamination. Contamination is the infiltration by foreign particles into a fluid power system. It first impairs, then shuts down system functions by causing blockages and wear in componentry such as motors, valves, and pumps. 80% of hydraulic failures are caused by contamination. The contamination removal process for hydraulic hoses and tubes just got a whole lot easier and less expensive thanks to ultra-clean technologies. The first step in contamination removal is to make sure that you have a filtered and regulated air or inert gas source. When a hydraulic hose is cut with either a metal blade or abrasive wheel, a tremendous amount of heat is generated, along with rubber dust and metal particles. Some of this contamination will stick to the hose tube as it cools. It is vitally important to clean the hose immediately after the cutting process. Load the recommended nozzle and ultra-clean projectile into the launcher's faceplate. Now close the faceplate of the launcher. The safety release bar will lock it into position. Insert the nozzle into the hose. Secure the other end of the hose into the catcher bucket. Depress the trigger until the projectile has exited the opposite end of the hose. Wipe the end of the nozzle clean and repeat this process now through the other end of the hose. The ultra-clean projectile strips out the internal contamination as it travels through the hose and around bends, forcing the contamination out in front of it. When crimping or swaging the end connections onto the hose, do not lubricate the stem of the fitting with lubricants that are not compatible with your customer's hydraulic fluid. This would recontaminate the hose you're cleaning. Use lubricant sparingly and start above the end of the stem. The crimping or swaging process causes stem collapse to achieve the proper coupling retention. Internal metal flash contamination will occur, and it must be removed. Tube assemblies should also be cleaned to remove metal particles and other contaminants. Before you clean the tube assembly, you should always deburr each end of the tube, make your bends, and flare the end of the tube if required. You should always fire the projectiles from the same end because the JIC and tube nozzle will clean the entire length. If rust or oxidation is present on the inner surface, you may need to use our abrasive projectiles until it is removed. The final projectile through the tube should be an ultra-clean projectile.